Okay, let's do an example. Let's use implicit differentiation to find the derivative of y with respect to x if we're given this equation, x plus y equals 3 plus y squared. The first step is always to take the derivative of both sides with respect to the independent variable. And I've messed this up, and I don't know how to use the eraser on my Live Scribe pen, so just bear with me. Now, notice I'm just saying the derivative of the left-hand side with respect to x. I want to know the instantaneous rate of change of x plus y with respect to x. I don't have dy dx here. I have the derivative with respect to x of this x plus y. Same thing, derivative with respect to x of 3 plus y squared. If I want to find dy dx, derivative of y with respect to x, the dependent variable's y, the independent variable's x, so I take derivatives with respect to x. Okay, now just use your derivative shortcuts that we're familiar with before. I've got the derivative of a sum, so that's the sum of the derivatives. Again, the derivative of a sum is the sum of the derivatives. What's the derivative of x with respect to x? It's just 1. What's the derivative of y with respect to x? All we can do is write dy dx. What's the derivative of 3 with respect to x? 3 is a constant, so that's 0. What's the derivative of y squared with respect to x? Now here, there needs to be a little red flag that goes up. Can't make my flag red because I don't have color, but a little red flag needs to go up in your mind here. I've got an outside function, a squared function, and an inside function, y. Now, y is not explicitly a function of x. Y is not sine x or cosine of x or x squared. But remember when we looked at our graph a minute ago, we said that this graph has many pieces, for example, the top half or the bottom half, that did pass the vertical line test, that were functions. So what you've got to think about is this y here is implicitly a function of x. Y is implicitly a function of x. That's this red flag I'm talking about. If you don't pay attention to that this is the dependent variable instead of the independent variable, you might just put 2y here. But I've got to use chain rule because the outside, derivative of the outside is 2y. But y is a function of x implicitly, although not explicitly. So the derivative of the inside is dy dx. Okay, now, what do I have? I have an equation with variable dy dx. The calculus is done. It's now all algebra. What I've got to do is solve the equation that's above for the symbol dy dx. Okay? Now, this equation's of this form. It's of the form 1 plus z, right? Z is dy dx, just 1 plus some variable is, some other variable. We'll call that a times z, right? This equation's just of the form 1 plus z equals something. We'll call this 2ya times z. I'm calling dy dx z. So if you wanted to solve this, for z, you would what? You would bring the 1 over to the right-hand side by subtracting 1 from both sides, since that's a positive 1. You would then subtract az from both sides, since that's a positive, plus az. So you bring from algebra, again, this is, I think, algebra 1 probably, bring the variables to the left. Now, I want z written just once. So it's written twice, though. So I'll factor out a z, and I get 1 minus a. And then to solve for z, it's 1 over 1 minus a. So what I want you to do is to solve this equation, 1 plus derivative of y with respect to x equals 2y derivative of y with respect to x, for the symbol derivative of y with respect to x, before you view the next Pencast.